Now it's all set up, I think. Yes. So sorry for the small text. I can't really do anything about that. It's just how this environment works. But at least it's a stream. So yeah, I've just been. So I'm going to participate in the Meta Game Jam, and I'm going to be using a library, a very small library, but it's still a library, and it's for rendering pixel-based graphics. And so I'm going to be using that and developing it a bit as well during this game jam. Get some experience using it, seeing what I can improve, and trying to optimize it a bit and stuff like that. And all I've done is I've added a canvas, and I should also add a script tag here, just so that I can actually do it in this nice file here. And what I'm doing as a coding environment, it's CodePen, because I can use that in school, and that's a very important part, because that's when I can code the most, right? Because it's a Chromebook and we can only do it online, so I can only use online stuff, so it's a bit limited. But CodePen has, you know, some very good tools, I think. See that you can have like a file explorer, you can have multiple tabs open, right? It's pretty nice. So yeah, I just shouldn't call it canvas. Should have learned that by now. And so there we go, and let context equals game screen dot get context 2D. Later I might implement some WebGL as well to optimize it even further, but I don't know at the moment. So we might have an init function and a frame function. And in the init we're going to call the frame, and the frame is just going to have an animation frame request here for it to itself. And I also want a resize thing, which is going to be responsible for resizing. I will show you a bit more about that later. And I will also have the, let's see here, the window texture. And so the window texture is going to be basically a texture. You can have this function called create texture. It creates a texture with the filled with all the color that you specify, and all the colors are RGBA. So for example, here I might do first we need the width and the height, and the width and the height in this library works a bit weird because you don't specify the width, right? This is 3 by 6 pixels. This is 2 to the 3rd by 2 to the 6th pixels, and the reason for this mostly is because then I can use tons and tons of bit shifting, and that is optimizing the game a lot. Also here I have my testing when I developed the library more, so I can, you know, get some code here to just see a bit more how I did things, so that it's not super wonky and weird. So yeah. Right. So yeah, I just need to think about what I'm supposed to do here. Yeah, I was going to check here. Yeah, it's 7 by 7 mostly, and I think that's this screen resolution, and I think that's going to be fine. What we can also do with this thing, you see it's a screen size. We can change the size, and this doesn't actually change the resolution, it just changes how big each pixel is in this canvas. So here they are smaller, and it improves performance a bit. Later I would of course want it to run the same performance independent of size, as well as even if it's just like a small improvement, because that would make a big difference, I think. But yeah, for now 7 by 7. And then we want to fill it with some color, and we might do like 0, bleh, that color. And I think in the library I want to do something easier to just put a texture onto a thing. So yeah, this is what I've been doing so far in this example, and it's pretty messy line of code. So I want to just find some way to more easily implement that, because that's just really weird and bad code. At least it looks like bad code. Yeah. So I have this thing called fill to image data. That's what I'm using, and I guess it's pretty clean actually. So I don't know. Something I want to test though, right? So what I'm doing here is I put this to the image data after I've filled it, but I want to just try to remove this and see what happens, if it still works. No. So I need that code as well. Basically what this does is it just we get the image data, we do stuff to it, we fill it with the Windows texture, and we put it back. So yeah, I don't know how nice that is, but we only need to do it once at least, so that's good. So put image data, and then we're going to do our window texture dot whatever this does. It's called fill to image data. Yes, fill to image data. And here we just get we have to get the image data first. Get image data, and it's 00 game screen dot width game screen dot height, because we want to get the full screen of data. Also in the put image data we have to put the 00. That means we put it at the top left corner, I think. And then we have some more features here. We have the offset X, offset Y, so that could just be 00, and scale up, which is the window size. It's going to be something like 2. This is also powered by 2, the same way that the width and height are. And then here we can just run this, see how it looks, and it doesn't do anything. Right, yeah. There is one more thing I need to do first. Okay, I need to say onload. I need to tell it to run the init function first. That's a pretty bad error. And now I don't know what's wrong. What is logs? Okay. So why isn't this working? I'm making a texture, that should work. I'm running this frame, and then I put the image data, and I fill image data from the window texture to the get image data here. Right, I don't see what's wrong. Go to image data. image data. This is just some weird offsets to make the screen follow it, and then screen size. Yep, and then 0, 0. Yeah, I've done exactly that, and I don't see what's wrong. Let's just put window size here, actually. But yeah, it doesn't work, and I don't know why. Oh, of course. Okay, I'm not sure if this is the all I need to do, but I need to actually tell it that the texture is a thing. So let's run this, and it still doesn't work. So no, that wasn't the only problem, seems. So what more problems are there? Let's try and pop this out into a different thing and see here what's going on. Right, create texture is not defined. Add init. Because it's a big C. That's what's wrong. At least one of the things that's wrong. Oh, now it actually works. Okay, so this is exciting. Exciting times. So you can see it's filled with this kind of a cyan color. And you know, I think it's pretty self-explanatory what this does. And we can close this down now because most of the complicated, weird, wonky stuff I've already gone through now. So we put the texture onto the canvas, and it should be draw the texture onto the canvas and request another frame from the window. Yeah. Alright, so in resize now, these are some more things that we need to do. I am going to say game screen dot width. Oh, I didn't think this through. I forgot about that. I need some more references here because this is a weird part as well. Yeah, soon it will pick up pace and be cool. Like this project, we can do stuff with it. But what I need now is this, because this is going to essentially allow me to, whenever I want, resize the screen. And this is going to, right now it's not, doesn't matter that much. But later it's going to, because eventually you might have like a slider or something that resizes the pixels if you need performance, and so then I can use that as a thing. Alright, so we got pretty much everything we need right now. Now the resize, we draw it to the canvas and all of that. So that's pretty neat. I'm just gonna type some stuff here. Okay. Yeah. So now I have that. Good. So I've been doing some other things as well that are weird. So in JavaScript, loading files is really annoying. So what I've been doing is I just been doing, you know, textures.js, and here I store all the textures as lists of numbers. And I mean, it's really weird, I know, but it's the easiest way, and since this is a game jam, I won't try to get some efficient file loading anyway. And so I have a program that can convert images and stuff, and that's what I'm using here too. You can see I'm here just loading some bricks. See this texture in the background and the fly. And the fly is actually being cut off, and I have some functionality in the library for that too. So I can animate him. So it's pretty simple. But of course, I don't have any good textures right now, so I'm going to have to do that a bit later. So let's start thinking about the game code. I'm not exactly sure how to do this. I'm thinking I should probably use a state machine. So maybe we could do something like let states, like so. Yeah. Wait, no. This is how you do it. So you do this, and then we say enum. So it is here, and yeah, so you usually lock it. Yeah, object.freeze. That's what I need. Object.freeze states. So now you can't change the states. That should be good. So now I can add some states. So I want an intro screen. So we have intro screen. I also want a a cutscene, right? That's something important that I want. I also want a start level, play level, and also level done. And I think those states are the most important. So from the intro screen, yeah, I also probably want, no, this is the menu. Then we also have the intro. I'm not sure what those called, you know, when they showed the like images of the company that did it and stuff. I can make some stuff for that as well, you know, like making an image for my YouTube account so that it kind of looks neat, and also making some, you know, meta thing for it. I guess I should just do like Trolled Woods intro, meta jam intro, and that should be fine. Yes, I think so. So now we should just make a current state, and then we can just put it to some states. We can say like states.trollwoods intro or meta jam intro, or the menu, or a cutscene, or whatever we want. We can set it there. Then I just need a switch statement to draw stuff for them. So here we can do pick a state, do stuff do stuff with no, implement the states machine. Yeah. So I just want to do the current state. We might make it something like play level. We also need a loaded level, but I'm going to do that in a bit. So we can do case state start the intro like so. MetaJam intro and menu case state start menu and case states dot cutscene. Also needs some sort of variables to keep track of which cutscene, which level, which menu, you know, that kind of thing. But I think it should be fine most of the time. Yeah, we could also do like settings menu, because that might be neat. Then we can do a settings menu break case cutscene case start level case play level and case level done. So quite a few things that are here, but they all make sense, kind of. I also need to add the state start here. Rest mode makes sense. Why do I have two cutscenes? Yeah, I just need one. Simple enough. All right. So now I want to implement some functionality for a tile map. Basically a map of textures where you have a couple of textures. You have a large texture with smaller textures inside it, and then you have a map that has certain objects basically for those different textures. And so if you see that specific object and you take that certain location in the texture and draw that. It sounds really complicated, but it's really not. They are extremely useful if you do stuff. So we might have something like, so we need some states here, or some variables that are useful. So for example, we need a countdown timer for all the things that might need those, like the all the intro things, and you know, the cutscene needs a timer, the start level needs a timer. You'll see what I mean by start level. It's like a small text that should come and do stuff, and level down might need some sort of timer. I don't really know. We might need to add a bunch more states as well, because this isn't that many states really. So we might say countdown timer is like 0, and so at each frame we want to count down the countdown timer. So we just do countdown timer minus at the moment. Later I will actually do some measurement of how the frame rate of the game to actually get a better countdown, but for now that should be fine. So what more do I need here? No, just cyan still. Yeah, so I'm going to start implementing some tile map stuff. So how does tile maps work? Yeah, I'm just thinking at the moment. Okay, I think I know kind of how to do this. So what we need is we need a I have kind of a cold, not really that bad, but a bit. So draw tile map is what we want, and so we need some sort of function to convert from tile map space. You know, like if we make tile maps for levels, we would presumably want to make something like let level an array of strings, basically. That's, you know, the most common way to make simple level editors. It's just you do this, and then you have different things represent different characters represent different tiles. So, you know, here we might have dots represent air, we have hashes represent normal ground, we might have underscores represent, you know, the top of some grass or something. And then you have, you know, everything uses this tile map. You have the editor, no, the renderer that renders it, and you have the physics engine that actually does physics with it. And all of those work. So, you know, it should work fine. So yeah, we can just use that level, I guess. Should be fine. Should work. Not be fine. It's that I should stop saying it should be fine, because it is fine. So here we just have the tile map that we want to use, and the tile map is just a big texture with multiple textures. We have the texture width and the texture height. So what this does is well, tile width and tile height. So of course powers of 2 still, because you need to be consistent. But these are basically saying how wide and how tall are the tiles, and so that basically will allow us to apply an offset and get different tiles. You'll see what I mean. It's basically the same as animations work. Actually, I don't need this, because they are actually applied in the texture here. We have the visible width and the visible height, and those are used for animation. And this is like it behaves like this was the width and height of the texture, but if you apply an offset to the X, it will move one visible width to the right, and if you apply an offset Y, it will basically take a separate area. I'm gonna do a better job explaining this, but yeah, let's just draw some stuff, because I want to just understand this myself. So if we have this here, and we take a brush and we draw some, and we have a box here. This is our texture, and it has some sort of drawing in it. No, we have like blah, blah, blah. And say we have different frames, basically. So we have this frame of animation, we have this frame of animation, we have this frame of animation, this frame, and this frame with Y for some reason. Then this is the width, as you can see. This right here is the width of the it's the width of the texture, and this is the height. But then we might, oh god, but then we might add some visible width and visible height as well. So what this does, it essentially separates these frames from one another, assuming that they are equally wide, and then we can say that this is visible width, and this is visible height, because they are as tall as you can see. You know, one frame is just the same height as the height of the entire texture. And then the offset x. So for example, let's say the offset x is 2. So this is offset x 0, off x 0, 1, 2, 3, and 4. And that's essentially how it works. And then if you have it in Y instead, then there's going to be like, so I have a frame here, then this is going to be offset Y 1. So it's basically a coordinate system of subtextures in a texture. It's a bit weird, but yeah, this is how it works. And I think it works pretty well. And the reason I use that is because of some features of the engine that yeah, you'll see. You might know this actually. So we draw a tile map. Did I just make a function for that? No, apparently not. I remove a lot of functions, or I remove a lot of unfinished functions. I don't know why. So when I draw the tile map, of course have the tile map texture, and it has its own specified tile width and tile height, so those I don't need to set. We also have a function that we can call if we see a character, or you know, a variable in the level data. If we see something in there, we can just set the value to that. So no, we can call that function, give it the value, right? So we have our tile map here, we have some data, like a staircase or something, and so what we do is it sees this character, right, a dot, and it says this dot, we put it into a function that we passed, and we get out a texture. So we get out this texture of like a face, and then we draw that out on the screen, right? So then we draw that into the corresponding screen on the big area here, you know, where we draw the tile map. Then we draw that face right there. Then it might have been, you know, there's a face for all the other dots as well, and there's like there's a black box for these, you know, a bit weird, but you get it, right? It's so that way you can specify textures, or well, really you specify offsets. You know, you specify the offset y and offset x for the tile, give that back, and then we can draw this happy little face. So yeah, it seems to be work. It should work. Okay, it just should work. We can use some bit shifting to make it like the maximum tile size is 256 by 256 or something, and then you just bit shift it 8 bits to the right to get the X component, and then just take the Y component minus the X component. Well, you take the X component is the data bit shifted 8 steps, which will basically remove the 8 first bits, 1 byte, and then we just say Y equals data minus X, because X bit shifted up. So now we just remove the first 8 things, and that should also be working. We can also, of course, do data and it with a 255. So this 255 is just 1 1 1 1 1 1 1 1, and if we add the data, we get just that first byte. So that should be a bit more elegant, actually. Okay, so we have our function that should give us back the tile. So we have the function basic char to tile offset, and we also need to tell where the upper left, what tile the upper left corner is. So you know where on our tile map is that upper left corner. And so we might do that as well. Actually, no, we just have an offset X and offset Y. That should suffice fairly well. And yeah, that should be all, really. Then we might also have to do some animated tile stuff later. But that should actually be possible using this system as well. We could just put that animation in this char to tile offset data. So it returns a different thing depending on what animation frame, animation index, or animation counter is on. Right, so yeah, I'm going to implement that, but not right now. It's going to be in a bit. So we're going to go through all of our width. So we're going to go through our width and height. Right? And so first we want to find, well, we really want to add the so we really want to just add yeah, I want yeah, I can't really think that well right now. It's too early and too little coffee right now. But I think I'm going to stop streaming right now, because I don't know if streaming lowers my productivity or anything. So I might not stream because then I have to talk, and talking takes up attention, and attention is important. So yeah, I will probably start streaming later and show some progress on the game once the development has picked up a bit. But for now,